Okay, your position looks good, Joe. Let's go Delta Scion.
Haven't gotten to 1 minute warning yet. One minute. Delta Sci. Push to test. Rock sign showing. Prime. Igniter ready light. Pre-cool on. Igniter idle. 20 seconds to launch. Everything checks here.
Your position is good, Joe.
Pump idle. Good pump. Good igniter. Ready to launch now. Good light. Okay.
This is the X-15 research aircraft, designed to investigate the problems of manned flight in a near-space environment. Altitudes up to 50 miles, speeds up to Mach 6. High-speed aerodynamics, aerodynamic heating, structural design, aircraft stability, and control in space and re-entry. This was the kind of information it was to provide, and provided it did. Here's the story. 57,000 pounds of thrust with a throttle attached. No engine like this had ever existed before, but Thiokol built one for the X-15. Now, what kind of airframe could be designed to carry such an engine?
The X-15 was designed and built to take the stresses encountered at hypersonic speeds, to go to extreme high altitude and to beat the heat, survive the extreme high temperatures that build up on the wing, fuselage, and tail during the re-entry to the Earth's atmosphere. The engineering research contribution we made at North American Aviation to the X-15 project was to take NASA's proposal to build this aircraft and to find out how they could be met.
Harrison Storms. He was in charge of the X-15 program at North American Aviation. The X-15 and its B-52 launch aircraft were ready. North American test pilot Scott Crossfield was ready. Step by step, the X-15 research project had moved to this important event. Now, the first of 3 X-15s was about to begin a series of test flights. The schedule called for an orderly progression of tests. In the first flights, the X-15 would remain attached to the B-52. Then a glide flight would be tried. Only then would powered flight be attempted. This careful program of flight tests, flown by pilot Scott Crossfield, proved the X-15 would do just what its designers hoped she would.
From March 10th, 1959 until late in 1960, when we delivered the 3rd aircraft to the Air Force, I made 14 captive flights, 1 glide flight, and 10 powered flights. It was all pretty much routine. We, North American that is, went up there to check out the aircraft, to check out the systems, to see how she handled and whether or not she'd meet the specs before we turned her over to the Air Force.
The pilot also goes through what is called trouble school, where failure of one or more of the X-15's major systems is simulated. Again, his reaction is monitored. Each pilot gets further practice by making a number of flights in a modified F-104 aircraft. He flies over his upcoming X-15 flight course to establish geographic checkpoints and key altitudes in the landing pattern. The range consists of a master station at Edwards and radar stations at Ely, Nevada and at Beatty. The flight corridor is 50 miles wide, and it contains a number of dry lake beds where emergency landings can be made. Two kinds of powered flights are made over the high range. One, a ballistic type, high-altitude run up to and even above 250,000 feet. And two, a high-speed run made at a lower altitude, usually 60 to 70,000 feet. During his practice flights in the F-104, the pilot must also familiarize himself with the timing and positioning for an X-15 landing at both primary and alternate landing sites. And he makes practice landings using predetermined settings that can simulate the low lift-drag ratio of the X-15. Nothing is left to chance, in the air or on the ground.
These precautions paid off during the following flight, when the pilot realized he could only get 30% power, and that consequently he would have to make an emergency landing at Mud Lake.
Ready to launch. 5, 4, 3, 2, 1.
That's a good light. That's a good light.
On a hot day, more than 12,000 feet of runway is required to achieve liftoff at 170 to 180 knots. Snugly tucked in the X-15 cockpit, the pilot is no doubt recalling the good old days before wing mounting, when he had to squeeze into the cockpit down through the bomb bay. This maneuver was accompanied by considerable huffing and puffing, and a big sigh of relief when he was finally strapped in the seat. Nothing to do now but sit back, relax, mentally help the B-52 pilot with his flying. Wing mounting of the X-15 permits the ejection seat to be utilized in an emergency, while the aircraft is still attached to the B-52 shackles. Launch checks continue as the pilot tests the attitude control rocket. The high-altitude control system used when the X-15 is on an altitude flight profile above the usable atmosphere. At extremely high altitudes, the conventional aerodynamic control surfaces are not sufficiently responsive for complete flight control. So attitude control rockets are necessary. Pitch and yaw rockets are located in the nose. Roll rockets are located on each wingtip. The underside of the X-15 is now building up a coating of frost on the outside of the liquid oxygen tank due to the intense cold of the liquid oxygen at a temperature of minus 300 degrees Fahrenheit. The auxiliary power units are now started. Note the exhaust trail going over the horizontal stabilizer. Launch. Slight roll-off occurs as the shackles release. The X-15 engine is started, and the aircraft accelerates rapidly, quickly leaving the B-52 far behind. On this flight, the plan called for a buildup of 1,500 pounds per square foot of dynamic pressure before pull-up. Again the launch. Photographed by X-15 camera number 1. Note the rapid acceleration as the aircraft drops away from the B-52, and the steep climb-out angle. Speed brakes are extended to permit longer burning time of the engine propellants and provide added aircraft stability during re-entry. Camera number 6 shows the control panel and the weightless condition. Note the pages on the pilot's flight checklist. The planned peak altitude accomplished, the aircraft starts on the downhill side of the parabola. As the descent angle increases, the horizon gradually disappears out of the picture. Now the pull-out to level flight. and the horizon once again is seen behind the tail of the aircraft. The pilot banks the X-15 to visually judge for himself the landing site relative to his position. The speed brakes close and the pilot guides the aircraft into an approach pattern for a landing on Rogers Dry Lake.
The X-15 research project has long since achieved its original goals. The aircraft has been flown successfully more than 120 times, and although setting new records wasn't its purpose, it has set a few along the way. Altitude, 67 miles. Speed, Mach 6, 4,104 miles an hour, the highest and fastest a winged aircraft has ever flown. Today, the X-15 moves on to further accomplishment. But now the Thoroughbred has become a workhorse, carrying a heavy payload of instruments, undertaking studies of the near-space environment possible before only with unmanned satellite and rocket-borne probes. There are many people who should share the credit for the continuing success of the X-15 research project. But perhaps they will understand if we seem to focus on those who have actually flown the many research aircraft since the X-1. By saluting these courageous men, we also pay homage to all the others who have helped us move step by step, deeper and deeper, into the unknown outskirts of space.